Finding the equation of a circle. If the centre and radius are given, or can be found, then using the formula x minus h to be squared plus y minus k to be squared equals r squared is the preferred method for finding the equation of a circle. However, for many questions, it is difficult to find the centre and radius. In these questions, we have to use an algebraic approach or rely on our knowledge of the geometry of a circle to find the centre and radius. Note, in some questions we can only use an algebraic approach. In using an algebraic approach, we let the circle be x squared plus y squared plus 2gx plus 2fy plus c equals 0 and use the information in the question to find g, f and c. Given 3 points P, Q and R on a circle. Method 1, algebraic approach. Let the equation of the circle be x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. Step 1, substitute each point into this equation. Step 2, this gives 3 equations in 3 unknowns g, f and c. Step 3, solve these equations for g, f and c. Step 4, put these values back into the equation. Method 2, geometric approach. Step 1, find equations of the perpendicular bisectors B1 and B2 of the chords PQ and QR respectively. The perpendicular bisector of a chord passes through the centre. So let's start with PQ. So this is the line PQ. So B1 is its perpendicular bisector. It cuts it in half and at a right angle. Then we have the chord QR, and its perpendicular bisector is B2, and again it cuts it in half at a right angle. And the perpendicular bisectors pass through the centre. Step 2, the centre of the circle is the point of intersection of B1 and B2. So B intersection B2 is equal to C. So we solve the equations of B1 and B2 simultaneously. So we solve the equations of the perpendicular bisectors to find the point of intersection. 3, the radius is the distance from C to P, or to Q, or to R. So from C to P will give us the radius, from C to Q will give us the radius, and from C to R will give us the radius. Step 4, use the formula x minus h to be squared plus y minus k to be squared is equal to r squared. Note, there is only one circle that contains the point P, Q and R. Points P minus 4, 2, Q minus 2, 6 and R 4, 8 are on a circle S. This is important that they are on the circle. Find the equation of S, the circle. Method 1, algebraic approach. We are given 3 points on the circumference of the circle. Let the equation of the circle be x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. We need to find the value of g, f and c. So minus 4, 2 is on the circle. So we swap each x for minus 4 with brackets, and we swap each y for 2 with brackets. We multiply out the brackets and we simplify. We end up with 8g minus 4f minus c is equal to 0. Bring any constants over to the right. Here we have equation 1 in terms of g, f and c. We do the same with minus 2, 6. Swap each of the x's for minus 2 with brackets, each of the y's for 6 with brackets. Multiply out the brackets and we get 4g minus 12f minus c is equal to 40. Again, bring the constant over to the right. This is equation 2. Then we do the same with 4, 8. So we swap each of the x's for 4, each of the y's for 8. We get 8g plus 16f plus c is equal to minus 80. And again, we bring the constants over to the right. This is equation 3. Now solve between the simultaneous equations 1, 2 and 3. So when we are solving simultaneous equations in the past, 3 simultaneous equations, we're usually solving for x, y and z, and usually we would try and eliminate z from each of the equations. We'd solve for x and y, and then we'd sub x and y back into one of the original equations to find z. So it's the exact same method, except this time we have g, f and c. So taking equation 1 and equation 3, we can straight away cancel out the c's because we're going to eliminate c from 2 different parts of the equations. So we're left with 16g plus 12f is equal to minus 60. And we can simplify to get 4g plus 3f minus 15. So now we have equation 4. So next we take equation 2 and equation 3, and again we can instantly eliminate the c's. We're left with 12g plus 4f minus 40. and simplifying we have 3g plus f equals minus 10. So here we have equation 5. So remember, this was equation 4, this was equation 5. Now we're going to solve between 4 and 5, so solve between these two equations to find the values of g and f. So here's equation 4, 4g plus 3f is equal to minus 15. And equation 5, we're going to multiply each term by 3, minus 3. So we get minus 9g minus 3f is equal to 30. Now the f's will cancel. And we're left with minus 5g is equal to 15, which gives us 5g is equal to minus 15, so g is equal to minus 3. Now we sub g into either equation 4 or equation 5, doesn't matter which. So we put g is equal to minus 3 into one of them. Let's go with equation 5. We sub the g for a set of brackets, put in minus 3. Minus 3 by minus 3 is minus 9, plus f is equal to minus 10. So f is equal to minus 1. So we have g, we have f, now we have to find c. So remember, these were our three original first equations, equation 1, equation 2, and equation 3, all in terms of g, f, and c. So we put g is equal to minus 3 and f is equal to minus 1 into 1, 2, or 3 to find the value of c. So let's go with equation 1. So we have 8g minus 4f minus c is equal to 20. Swap the g for a set of brackets, put minus 3 in. Swap the f for a set of brackets, put minus 1 in. So multiplying out the brackets and simplifying, we end up with c is equal to minus 40. So now we have g, we have f, we have c. So we put g is equal to minus 3, f is equal to minus 1, and c is equal to minus 10 to find s. So the equation of a circle is x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. This is given in our formula book. Swap the g for a set of brackets, put minus 3 into it. Swap the f for a set of brackets, put minus 1 into it. Swap the c for a set of brackets, put minus 40 into it. Or you can just straight away put in minus 40 since there's no letter attached. So we have x squared plus y squared minus 6x minus 2y minus 40 is equal to 0. And this is the equation of circle S. So here we have method 2, the geometric approach. The diagrams on the right represent the situation. We find the equation of B1, the perpendicular bisector of PQ. So P and Q were given to us in the question. So there's P and there's Q. So this is the chord length PQ. So we want to get the perpendicular bisector. So that's that red line there. Remember, the perpendicular bisector goes through the center. Then the equation of B2 and the perpendicular bisector of QR. So Q and R, the points were given to us in the question. So there's the chord QR. So the perpendicular bisector of QR is this green line. And the two perpendicular bisectors, so the green line and the red line, they intersect at the center, 3, 1. But obviously we have to come up with this ourselves. So the center C is the point of intersection of B1 and B2. The radius is PQ or QC or RC. So PC will give us the radius, QC will give us the radius, or RC will give us the radius. So we're going to start off by getting the slope of RQ. So there's R and there's Q, so we have the 2 points. So 4, 8 and minus 2, 6. So using our slope formula, subbing into our slope formula, we end up with a third. So the slope of B1, the perpendicular bisector, will be minus 3. So we turn this upside down and change the sign. So the slope of the chord is a third. So the slope of the perpendicular bisector, highlighted in yellow there, will be minus 3. Now if we get the midpoint of RQ, the chord, we will find a point that is also on the perpendicular bisector. So we'll find a common point. So using our midpoint formula, we substitute into our midpoint formula with 4, 8 and minus 2, 6, and we get 1, 7 to be the midpoint. So that's at point A. So we know A is on the perpendicular bisector. We also know the slope is minus 3. So using that into our formula for the equation of a straight line, y minus y1 equals m times x minus x1. We have a slope of minus 3, a point 17, and we end up getting 3x plus y minus 10 is equal to 0. So that's the equation of the perpendicular bisector highlighted there in yellow. In the same way, we take the other 2 points, P and Q. So P is minus 4, 2 and Q is minus 2, 6. So that's the chord. So again, we're going to get the slope of that chord. So using minus 4, 2 and minus 2, 6, we sub into our slope formula. We get a slope of 2. Turning it upside down and changing the sign, the slope of B2, the perpendicular bisector, is minus a half. So the slope of the perpendicular bisector is minus a half. Again, we want to get the midpoint of PQ. So again, minus 4, 2 and minus 2, 6, we use our midpoint formula. We sub into our midpoint formula to get minus 3, 4. So that's that point B there. That's the midpoint of the chord, which also happens to belong to our perpendicular bisector. So now we have a point on our perpendicular bisector. It happens to be minus 3, 4. We also have the slope minus a half, so we substitute those into the straight line formula. So y minus y1 equals m times x minus x1. And we end up with the equation of B2, the perpendicular bisector, being x plus 2y minus 10 is equal to 0. So now we have the equation of the other perpendicular bisector. Solving the simultaneous equations for B1, the first perpendicular bisector in the previous slide, and B2, the second perpendicular bisector, gives a centre C 3, 1. So we have the centre 3, 1. The radius of S, the circle, is the distance from P to C. So from P to C, or from Q to C, or from R to C. So let's go with P to C. So P is minus 4, 2 and C is 3, 1. So there's minus 4, 2 and 3, 1. So if we get the distance between these 2 points, point on the centre point and a point on the edge, we get the radius. So our distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So using these points, we substitute into the formula to get the square root of 50. Thus, the centre of S is 3, 1. And the radius length is the square root of 50. So the equation of S is x minus h to be squared plus y minus k to be squared is equal to r squared. Swap h for 3, k for 1, r for root 50. We get x minus 3 to be squared plus y minus 1 to be squared is equal to 50. And multiplying out the brackets and bringing everything over to the left hand side, we get x squared plus y squared minus 6x minus 2y minus 40 is equal to 0, which is the same equation as we got using the algebraic method. Now personally, I would prefer the algebraic method. It's something that we already know from our algebra chapter, and it's much quicker. Given 2 points P and Q on the circle and the equation of the line L containing the centre C minus G minus F. Method 1, algebraic approach. Let the equation of the circle be x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. 1. Substitute each point into this equation. 2. Substitute minus g minus f into the equation of the given line L. 3. This gives 3 equations and 3 unknowns g, f and c. 4. Solve these equations for g, f and c. 5. Put these values back into the equation. Method 2, geometric approach. 1. Find the equation of B, the perpendicular bisector of PQ. 2. Solve the simultaneous equations L and B to find the centre. 3. Find the radius or the distance from the centre C to P or Q. 4. Use the formula x minus h to be squared plus y minus k to be squared is equal to r squared. So here's our centre minus g minus f. Here's our circle. Here's our line L, our line B, our chord QP. And remember that B is the perpendicular bisector of QP. Find the equation of the circle that contains the points minus 4, 1 and 3, 0 and whose centre lies on the line x minus 2y plus 11 is equal to 0. Method 1, algebraic approach. We are given 2 points on the circumference and the equation of a line containing the centre. Let the equation of the circle be x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. So minus 4, 1 on the circle, so we swap each of the x's for minus 4 with brackets, each of the y's for 1 with brackets. Multiply out the brackets and simplify. We get 8g minus 2f minus c is equal to 17. So letters on the left and the constants on the right. So this is equation 1. Doing the same with the point 0, 3, we'll swap each of the x's for 0 with brackets, each of the y's for 3 with brackets, multiplying out the brackets, and simplifying we get 6f plus c is equal to minus 9. So letters on the left and constants on the right, and notice that there is no g term, that's fine, and this is equation 2. So the centre minus g minus f is on the line x minus 2y plus 11 is equal to 0. Thus, minus g minus 2 times minus f plus 11 is equal to 0. So what we've done here is we've swapped the x for a set of brackets and put minus g into it. swap the y for a set of brackets, put minus f into it. So simplifying, we get g minus 2f is equal to 11. So letters on the left and constants on the right. So this is equation 3. So what we want to do is eliminate c from equation 1 and equation 2. So this was equation 1, this was equation 2. So we just write them down again. We notice that the c's will cancel, which is what we want. And then we simplify. So we have 8g plus 4f is equal to 8. We simplify by dividing across by 4. So we get 2g plus f is equal to 2. So here we have equation 4. So this is equation 3 and this is equation 4. So remember, this is equation 3 and this is equation 4. Now solve between equation 3 and equation 4 to find the values of g and f. So here we have equation 3. And then we take equation 4 and we multiply by 2. So we get 4g plus 2f is equal to 4. Now our f's will cancel. We get 5g equals 15, so g is equal to 3. So now we're going to substitute g into either equation 3 or equation 4. So we're going to go with equation 4. So we swap the g for a set of brackets, put 3 into it, and we get f is equal to minus 4. So now we put g is equal to 3 and f is equal to minus 4 into equation 1 or equation 2 to find the value of c. So let's go with equation 2. So this was on a previous slide. So 6f plus c is equal to minus 9. Swap f for a set of brackets, put minus 4 into it. So we end up with c is equal to 15. So now we have g, we have f, and we have c. We substitute the three of these into the general equation. So the equation of a circle is x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. This is given in our formula books. Swap the g for a set of brackets, put 3 into it. Swap the f for a set of brackets, put minus 4 into it. Swap the c for 15. We get x squared plus y squared plus 6x minus 8y plus 15 is equal to 0. So here we have the equation of the circle. Note, using method 2, the geometric approach gives the same result, but it would just be longer. Note, a line perpendicular to a tangent at the point of tangency passes through or contains the centre of the circle. So here we have a tangent. Here we have a line perpendicular to it. So this line must pass through the centre of the circle. Given 2 points P and Q on the circle and the equation of the tangent at one of these points. 1. Find the equation of L, the line perpendicular to the tangent, T, passing through the given point of contact. This line will contain the centre C. 2. Now we have 2 points on the circumference of the circle and the equation of a line that contains the centre of the circle. 3. Use the algebraic approach, as in the previous example, or use a geometric approach. So here we have the circle. Here we have the tangent T. We're given the points P and Q that are on the circle. We know that the line that is perpendicular to the tangent must pass through the centre. And we also know that the perpendicular bisector of the chord QP also passes through the centre C. Find the equation of the circle that passes through the point A minus 3 minus 2 and B 0 minus 1, and where the line 2x minus y plus 4 is equal to 0 is a tangent at the point A minus 3 minus 2. So here's our x-axis, here's our y-axis, here's our circle. We know that we're looking for the equation of the circle. We know that it passes through A minus 3 minus 2, so there's A minus 3 minus 2, it's on the circle. And it passes through B 0 minus 1, so that's also on the circle. And we know that there is a line, 2x minus y plus 4 is equal to 0, and that is tangent at the point minus 3 minus 2. So, method 2, geometric approach. The diagram on the right represents a situation. Find the equation of L, the line that is perpendicular to the tangent T, at the point of contact A minus 3 minus 2. This line contains the centre C. So we're looking for the equation of the line L. So this line is perpendicular to the tangent T, and we know that it goes through the centre. And the point of contact between the tangent and the circle is minus 3 minus 2. Find the equation of B, the perpendicular bisector of AB. So there's A minus 3 minus 2. There's B 0, 1. So we want to find B, the perpendicular bisector. The centre C is the point of intersection of B and L. So there's B, the perpendicular bisector. And there's the line L. And the point of intersection will give us the centre. And the radius is the distance from A to C, or the distance from B to C. So the slope of the tangent 2x minus y plus 4 equals 0 is 2. So if we label A, B and C, and we know that the slope of a line is minus A over B, so it's going to be minus 2 over minus 1, which is 2, so that's where the 2 comes from. So the slope of this tangent T is 2. So the slope of L must be minus a half, because remember L is perpendicular to T. So 2 is really 2 over 1. Turning it upside down and changing the sign gives us minus a half. So the slope of the green line is minus a half. We also know a point that's on the green line, minus 3 minus 2. So subbing those into the equation of a straight line, y minus y1 equals m times x minus x1. So the slope is minus a half, a point on the line is minus 3 minus 2. We get the equation of the line to be x plus 2y plus 7 is equal to 0. So this is the equation of the green line. And remember that this green line passes through the centre. Next we want to get the slope of AB, which is the chord. So remember A is minus 3 minus 2 and B is 0, 1. So there it is on our diagram, the blue line. So we want to get the slope of this blue line. So using the points minus 3 minus 2 and 0, 1, minus 1, we substitute into our slope formula. We get 1 over 3. So the slope of the yellow line, which is the perpendicular bisector of the blue chord, is going to be minus 3, because we turn this upside down and change a sign. So the slope of the yellow line is minus 3. Now if we get the midpoint of the blue line, we get a point that is on the yellow line. So using our midpoint formula and using the points minus 3 minus 2 and 0 minus 1, we end up getting minus 3 over 2, comma minus 3 over 2 to be the midpoint of the blue line. So this point must also be on the yellow line. So we're going to use the slope of minus 3 and the midpoint, which is minus 3 over 2, comma minus 3 over 2. Sub them into the equation of a straight line, y minus y1 equals m times x minus x1. And we get 3x plus y plus 6 is equal to 0. So this is the equation of the yellow line. Now we want to solve the simultaneous equations L and B. So we want to get the equation of L, which was on the previous slide, and the equation of B, which we just worked out here. Solve them simultaneously to get the centre to be C minus 1 minus 3. So there's our centre there, C minus 1 minus 3. So this is just showing how we got C minus 1 minus 3. So we had x plus 2y plus 7 is equal to 0. So we bring the 7 over the equal sign, so we have x plus 2y is equal to minus 7. And we had 3x plus y plus 6 is equal to 0, so bringing the 6 over the equal sign, we get 3x plus y is equal to minus 6. Multiplying across by minus 2 means our y's will cancel, so we end up getting x is equal to minus 1. And subbing x equals minus 1 into either of these equations, we end up with y is equal to minus 3. So just proving that this is indeed the point of intersection of these two lines, which also happens to be the centre of the circle. So now we need to get the radius. So the radius is the distance from A to C or the distance from B to C. So it doesn't matter which one you go with. So we'll go with A to C. So we have the point A, which is minus 3 minus 2, and the point C, the centre, minus 1 minus 3. So substituting into our length formula, we get root 5, that's the radius. Thus the centre of the circle is minus 1 minus 3. The radius is root 5. So the equation of the circle is x minus h to be squared plus y minus k to be squared is equal to r squared. So swapping the h for 1, well, the minus 1, so minus minus 1 gives us plus 1. And swapping the k for minus 3, so we get minus minus 3, which is plus 3. And swapping the r for root 5, we end up with x plus 1 to be squared plus y plus 3 to be squared is equal to 5. And multiplying out the brackets and bringing everything over to the left, we get x squared plus y squared plus 2x plus 6y plus 5 is equal to 0. Note, after finding the equation of the line L, we could have let the equation of the circle be x squared plus y squared plus 2gx plus 2fy plus c is equal to 0 and used an algebraic approach to find the values of g, f and c. Given the length of the radius. In some questions we are given the length of the radius. When this happens, we let the square root of g squared plus f squared minus c be equal to the given radius, then we square both sides. We then have to use the other information in the question to form two other equations in g, f and c, and substitute these into the first equation to get a quadratic equation in one variable. In general, we end up with two circles that satisfy the given conditions. A circle of radius length root 20 contains a point -1, 3. Its centre lies on the line x plus y is equal to 0. Find the equation of the two circles that satisfy these conditions. So let the circle be x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. What's given to us is that the radius is equal to root 20. So we take our radius formula, the square root of g squared plus f squared minus c, and we let it equal to root 20. We square both sides, getting rid of the roots, so we get g squared plus f squared minus c is equal to 20, and this is equation 1. We know that it contains a point -1, 3. So we swap each of our x's in our circle equation for -1 with brackets. We swap each of our y's for 3 with brackets. And multiplying out the brackets and bringing the constant over to the right, we get 2g minus 6f minus c is equal to 10. So this is equation 2. The centre is minus g minus f, and this is on the line x plus y is equal to 0. So swapping the x for minus g, the y for minus f, we get minus g minus f equals 0. And just multiplying across by 1, minus 1, we get g plus f is equal to 0. So this is equation 3. We now have to solve between the simultaneous equations 1, 2 and 3. So here's equation 1, equation 2 and equation 3. So we have to solve simultaneously. So again, here's equation 1, equation 2 and equation 3, and we need to solve them simultaneously. So starting with equation 3, g plus f is equal to 0. We solve for f, so f is equal to minus g. We substitute this expression for f into equation 2 to find c in terms of g only. So here we have equation 2. So we swap the f for a set of brackets, we put minus g into it, because we know f is equal to minus g. And then multiplying out the brackets and solving for c, we get c is equal to 8g minus 10. Now we have f and c in terms of g, we put these into equation 1. So we have g squared plus f squared minus c is equal to 20. We swap f for a set of brackets, put minus g into it. We swap c for a set of brackets, put 8g minus 10 into it. And then we multiply out the brackets and we simplify. So we end up with a quadratic, g squared minus 4g minus f is equal to 0. We factorise and solve to get g is equal to minus 1. Or g is equal to 5. So we got f is equal to minus g, c is equal to 8g minus 10, and g is equal to minus 1 or 5. So case 1, let's start off with g is equal to minus 1. So f is equal to minus g. So, and we know g is minus 1, so that's going to be minus 1, which is 1. So f is equal to 1. We know c is equal to 8g minus 10. So swapping g for minus 1 with a set of brackets. We get 8 times minus 1 minus 10, which is minus 8 minus 10, which is minus 18. So c is equal to minus 18. So our equation, again, from our formula book, is x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. We swap the g for minus 1 with brackets, the f for 1 with brackets, the c for minus 18. We get x squared plus y squared minus 2x plus 2y minus 18 is equal to 0. So this is one equation of the circle. Our other option is that g is equal to 5. So let's see what happens there. So if g is equal to 5, we know f is equal to minus g, which will give us minus 5 because g is equal to 5, so f is equal to minus 5. We know c is equal to 8g minus 10, so we swap g for a set of brackets, we put 5 in, So we get 8 times 5 minus 10, which is 40 minus 10, which is 30. So C is equal to 30. So again, we have our general equation of the circle. We swap G for a set of brackets, put 5 in, F for a set of brackets, put minus 5 in, and we swap C for 30. And multiplying out the brackets and simplifying, we get x squared plus y squared plus 10x minus 10y plus 30 is equal to 0. So this is our second equation of the circle.